Okay, 1, 4. So it says for the function f of x equals 1 over x minus 2, determine each of the following values. So what is f of 4? So I'm going to do f of 4 and just substitute 4 in the place of x. So that's going to give me f of x is 1 over x minus 2. So that's going to be 1 over 4 minus 2, which would be 1/2. And then the second part says, what is x when f of x is 1? So that means you're getting the input that gives you an output of 1. So instead of placing 1 and substituting x for 1 or 1 for x, I'm going to substitute 1 for f of x for the output. So then 1 equals 1 over x minus 2. And you might be able to just do that in your head. 1 is equal to 1 divided by 1. So how are you going to get a 1 out of this? That would have to be a 3. If you weren't sure, you could just cross multiply. So x minus 2 equals 1, x equals 3. Okay, part A, part B. 1/5, Carmichael makes a function machine. The inner workings of the machine are visible in the diagram at right. What will the output be in each of the following cases if a 3 is dropped in? So I'm going to drop in a 3. We've got f of x equals x squared plus 2x plus 1. So f of 3 would be 3 squared plus 2 times 3 plus 1. So that's going to give me 9 plus 6 plus 1. So 9 plus 6 is 15, and 15 plus 1 is 16. Okay, and then part B, what if we drop in a -4 into this function machine? So you do need to be careful with a negative when you're squaring it. So you're putting -4 in the place of x. So that means you're squaring -4. Most common mistake here is people will just write this and wind up with a -16, but you're not squaring 4 and taking the opposite, you're squaring -4. Okay, so plus 2 times -4 plus 1, so that's going to give me 16, positive 16, plus -8, or -8, which would be 8, plus 1 is 9. Okay, negative 22.872, so let's use a calculator here. I'm just going to substitute negative 22.872 in the place of x. So that's going to give me, and you could do this on Desmos. Notice how I'm putting negative 22.872 in parentheses. Okay, so that gives me 478.38. All right, 1/6. Angelica is working with two function machines. G of x equals the square root of x minus 5, and h of x equals x squared minus 6. She wants to stack the two machines so that the output of the first machine becomes the input of the second. Her beginning input is 6. In what order must she put the machines to get a final output of 5? Okay, so we've got these two functions. And her input is 6. Her beginning input is 6, and she wants the output to be, what order are we going to put these in so that our output, okay, well, I happen to know that it's h first, so I'm going to just save some time and not do the other way. So for part A, if I do h of 5, that gives me 5 squared minus 6, which is 25 minus 6, which is 19. Oh wait, you know what? I think it's G first. No, it is H first. Oh, I'm putting a 5 in there. Whoopsie. 6 is the input. I was looking over here. So 6 squared minus 6. So 36 minus 6 is 30. And then if I do G of 30, that gives me square root of 30 minus 5, which would be square root of 25, which is 5. So H first, G second gives you an output of 5. And then part B says, is it possible for her to get a final output of -5? If so, show how she could do that. If not, explain why not. If you do the opposite order, you will get, so if I do, what did it say? Is it possible to get a final output of -5? Oh, okay, with the same input. So G of 6 will give you, wait, I'm missing some. Is it possible for her to get a final output of -5? So G of X, are we using an input of 6? Oh, yeah, okay. So square root of 6 minus 5 would be square root of 1, which is 1. I'm kind of rushing. And then if I do H of 1, that gives me 1 squared minus 6. So 1 minus 6 would give you a -5. So it is possible if G is first. Okay, for 7, it says, in this course you will learn strategies that allow you to make sketches of many different types of graphs. However, when the directions tell you to make a complete graph, this means you must do more than make a quick sketch. So you want to use graph paper. I saw some folks not using graph paper. Please use graph paper for all graphs. Plot your points accurately. Your X and Y intercepts should be on the graph if they exist. And you should not just be copying a picture from Desmos, ideally. If you use Desmos, that's fine, but try to get those intercepts correct and any maximums or minimums, kind of like what we were doing with 1-3, where, 113, where it gives you these key points. You want to make sure you're showing all of these characteristics of your graph very carefully when you're graphing. Okay, so on let's see, we're going to do -2x plus 7, so just a linear equation. Let me grab my little straight edge. Okay, so this is 17a. Okay, and it's y equals -2x plus 7. So I kind of visualize what this is going to look like before I start sketching it. It's going to have, I'm going to just do a little sketch over here. It's going to have a y-intercept of 7, and the slope is negative, and it's pretty steep. So it's going to look like that, and that will help me to just fit this on my graph paper a little bit better. And make sure that I put the x-axis low enough that I can actually fit that y-intercept on there. Okay, +7 is my y-intercept. -2 is my slope. So I'm going to go down 2 over 1, down 2. And there you go. I love this little triangle. Hopefully you have a ruler, or you're going to get a ruler, and make sure you have that graph paper notebook. For 3/5 x plus 1, that's going to be a y-intercept of 1 and a slope of 3/5, which is less than 1. Remember, 1 would be at a 45-degree angle, so less than 1. So it's going to look kind of like this. So let's think about that as we put this x and y axis on the graph paper. All right, y-intercept is 1. I'm going to go up 3 and over 5. And then I'm just going to go backwards, down 3 and over 5. All right, part C. We have a linear equation in standard form, 3x plus 2y equals 6. I don't know if you can graph that in Desmos or not without putting it in y-intercept form. So let's just change it over to y-intercept form and get y by itself. So I'm going to move this 3x over here. And I like to put the x term first, doesn't really matter though, and then divide both sides by 2. So that's going to give me y equals negative 3/2 x plus 3. So that's going to be a negative slope. It's going downhill with a y-intercept of 3. So give yourself enough room so that you can fit that y-intercept on there. And your x-intercept, those are the main points I'm looking for. So 3 is my y-intercept. I'm going to go down 3 over 2, down 3 over 2, and there you go. Okay, part D, we have y equals x squared. Our friend, the parabola. So hopefully you know what this looks like. Did a lot of work with that last year, right? Okay, so 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. And you could just come up here. I just do this 4, 4, 5, 6, 7, 8, 9. And I know the value at positive 3 and negative 3 is 9. And that's plenty. Key points there would be a minimum of 0, 0, and showing that symmetry. For 1-8, it says the graph for part D is different from the other 3 graphs. Explain how it's different and what in the equation makes it different. Well, it's different because it's not linear, right? So you could just add on your graph paper, not linear. Makes it different because you've got an exponent. The other ones do not have an exponent. So this is 1, 8, A and B. For C, it's called a parabola. It's asking us what is this called. This is called a parabola. And the domain and range for part D, your domain. Well, domain is any possible x value. Well, there's no restriction here. For y equals x squared, the only time you're going to have a restriction on your domain is when you have a square root or if you have some type of fraction. Those are the cases where your domain is going to be affected. If it's being squared, if it's linear, if it's cubic, it's not going to have a restricted domain. So domain would be all real numbers. You could just write all real numbers. You could also do this. X is between negative and positive infinity, not including those because there's no such number as infinity. You could also do this. Whoops. So you would do open parentheses. Oops, I forgot the negative. Negative infinity to infinity. Range. Well, this graph doesn't go any lower than 0. It does intersect 0. You do have the point 0, 0. So then all your possible y values that's your range. So you've got y values from 0 all the way going up to infinity. Range is or domain is your x, all your possible x values. Range is all your possible y values. So for range, we're going to say, you could say, I'm going to abbreviate here from y greater than or equal to 0. You could write it like that, or you could do 0 to infinity with the bracket notation, or you could write in words all numbers greater than or equal to 0. I'll write it out. All right, I'm going fast because I'm trying to get this done before my lunchtime. And if you would like to have these in advance, I can certainly crank those out. And if that's going to be a better way to do homework, I kind of like seeing what you know how to do in the beginning of the year without a video. Okay, so we're just doing a little equation solving for 1, 9. Oops, 3x. Please use pencil. I think I saw most people were using pencil. So we want to distribute here. That's going to give us 4x minus 4. I like to think that this is a negative 2. So negative 6x and negative 30 turns into negative 6x minus 30. I'm going to combine like terms on the left. That's going to give me negative 2x, and then negative 4 and negative 30, negative 34. And then I always say get rid of the smaller x value when you have x's on both sides. Negative 3 is smaller than negative 2. And then that just means you wind up with a positive coefficient for x. So add 34 gives me 33. And that is not right. I missed something. Let's see. 4x minus, did I write this out right? 2, 3, negative 3x minus 1. Okay, what did I do wrong? 4x minus 4, negative 6x minus 30, negative 3x minus 1. So that's negative 2x minus 34 plus 3x minus 34. I think I wrote something wrong. Hold on. I wrote a 30 where I should have written a 10. So that's going to be negative 14. So that's going to be 13. There we go. Alrighty. B is okay, when I see a negative outside of those parentheses, I just flip the sign of everything in the parentheses. And then let's go ahead and combine like terms. So that's going to be 1.5x plus 7. And then we've got x's on both sides. 1.5 is smaller. Let's get rid of that. Add 5, and then 12 divided by 3 over 2 is the same as 12 times 2 over 3, which would be 24 over 3, which would be 8. Oops, sorry about that. Okay, for 110, we're going to use area model and multiply these expressions. So let's see, we've got (5m minus 1) and m plus 2. So that's going to give me 5m squared, 10m minus m minus 2. So that's going to be 5m squared. We've got like terms. Plus 9m minus 2. 6 minus x and 2 plus x. So that's going to give me negative x squared right here. Let's see, so negative x squared, combine like terms, plus 4x plus 12. A few people got this one wrong, of the people who did turn in their work, and I was able to see it. Hopefully we get that Schoology figured out. Let's see, that's going to be 25. I think some of you were thinking this was a difference of 2 squares, but it's not. So that's 25x squared, that's y squared. This is going to be minus 5xy, and this is also going to be minus 5xy. So that's going to give me 25x squared minus 10xy plus y squared. And last we have, all right, let's just distribute 6x squared minus 30xy plus 12x. Okay, I will get this up on my YouTube channel, and hopefully this helps.